Grade 12, grade 11. After this lesson, you will never ever get stuck in trig identities. I'm talking about questions like these ones where we simplify, we prove the left-hand side is equal to the right-hand side, and the whole shebang. In this lesson, we will learn how to start a question, how to continue, and how to finish the question. Now, a reminder, in grade 12, we need to know 6 types of identities. That's 1, 2, 3, 4, 5, and 6. For grade 11, only the first 4 apply. The first one is the tangent identity. This is where we take tan of anything and change it into sine over cos. Next, square identities. Sine squared theta plus cos squared theta is equal to 1. And from that, we can also make sine squared theta the subject of the formula or cos squared theta the subject of the formula. Then reduction angles identities, where the main angles are 90, 180, 270 is usually not applicable in the CAPS curriculum, and the other main angle is 360. Then 30, 45, 60, these are called special angles. Now, reduction angles are based on a CAS diagram. All students take coffee. So this is where we have the first quad, second quad, third quad, and fourth quad. And when we are moving in an anti-clockwise direction, the first quad here, this angle is theta. And if we go in a clockwise direction, the fourth quad will give us negative theta here. And the rest of the angles here use the main angles as the reference, 90, 180, 360. Like in the first quad here, we have 90 minus theta. Next quad 90 plus theta, and so on. Hopefully you guys remember this CAS diagram. Otherwise, we have an alternative method for those who don't prefer using a CAS diagram. The next identity is negative angles here, where we assume this negative theta is an angle in the fourth quad. Watch this. Remember, in the fourth quad, cos is the only trig ratio or trig function which is positive. And our angle is negative theta right here. So cos is positive, sine is negative, and tan is negative, which is why sine of negative theta here will give us negative sine theta. Cos of negative theta will be positive cos theta because cos is positive in the fourth quad. Tan of negative theta will be negative tan theta. The next identity is the double angle identity. We have the identity for sine right here, and cos has 3 identities. So we don't have to memorize these ones. They are provided for on your grade 12 question paper formula page. Then the last identity will be compound angle identities. The ones for sine and the others for cos. Now let's do some past exam questions, and this is our first question. As we do each question, we will check which identity is applicable. Sometimes we will factorize where applicable. If we are adding 2 or more fractions, we are going to be applying the LCD, lowest common denominator. In some questions, we may need to simplify both the left-hand side and the right-hand side to prove the identity. Sometimes we're going to be applying just our general knowledge in mathematics, like, say, the knowledge of exponents. Otherwise, remember this process. Trig identities will be about which identity is applicable out of these 6. Factorization sometimes, LCD sometimes both left-hand side and right-hand side, or just general knowledge. Here's our first question. Determine the value of all of these. So firstly, guys, this is a grade 12 and a grade 11 question. So how do we approach this question? We are going to check which identity is applicable. So whenever we see 180, 360, 90, another 180 here, that has to be reduction angles. Now to do reduction angles, we have 2 options. The CAS diagram. Like in this case, for example, we are given cos of 180 plus x. So 180 plus x in the CAS diagram is the angle in the third quad, where only tan is positive. Sine and cos are negative. So when we do this question right here, cos of 180 plus x, we are going to write it as negative cos of x. That's according to the CAS diagram. But watch this. Since these reduction angles are all about whether the trig ratio is positive or negative, we can use another alternative method. I call it one and done method. One and done. What we do, in the place of x here, wherever we see x, since x can take any value, so we can just choose to substitute 1 in the place of x to find out whether cos is positive or negative, next tan is positive or negative, sine is positive or negative, and all that. Okay, let's do it. In the place of x, we are putting 1. Use your calculator. On your calculator, enter cos of 180 plus 1. What are you getting? You are getting a negative sign. Just like that, by putting 1, we are done with the sign. 1 and done method. What about tan, the next one here? Let's do it. 360 minus, in the place of x, put 1. Tan of 360 minus 1 will give us another negative sign. So 1 and done. So for now, we are working out the signs, guys. We are still going to write the answer in full. Next, sine squared of 90 minus 1. Remember, guys, anything which is squared, whether it's a positive or a negative, if it is squared, it will end up as a positive. So in this case, we didn't really need to test using 1. We just know that whatever the sign we are getting here, because we have a square, whenever you square something negative, let's say negative 1 squared or negative whatever squared, that will always give us positive. Next, what about this one? 180 minus x. So enter on your calculator sine of 180 minus 1. Where there is x, you just put 1. What are we getting? We are getting another positive. Reduction angles are done. Now let's write the answer in full. So cos of 180 plus x, we already know this is going to give us negative. So that's going to be negative cos of x. Tan of 360 minus x, we already worked it out to be negative. So in brackets, write it as negative tan of x. Now be careful here when you write the answer, because if we just write it as negative tan x, not in brackets, it seems like this is a minus, but it's a multiplication, guys, because cos is multiplying tan here. The next one, sine squared 90 minus x, we already know we are getting a positive. But remember the rule when it's 90 degrees. And 90 degrees is called a coratio. It's a coratio identity. Whenever you see 90 degrees, sine must be changed into its coratio. What is the coratio of sine? That's cos, which is short for cosine. So whenever we see 90, we change sine into cos. If it's cos, we change it into sine. So here we are getting positive cos squared x all over. Now the denominator, we already worked it out as positive. So when it's 180 and 360, we don't change that into a coratio. Sine remains sine. So this is going to be positive sine x. Not forgetting our lovely sine squared x at the end there. She probably thinks we forgot about her. Since we have some brackets here, let's just remove them by multiplying. So negative cos and negative tan will give us positive cos x times tan x times cos squared x all over sine x. Not forgetting plus sine squared x at the end here. Then next, remember guys, I don't want any one of us to get stuck. So what we do, we still follow this process here. In what we have so far, we have to check which one of these identities is applicable. Okay, let's see. Cos x is not an identity. We'll just repeat it. But tan x is this one here. The first identity right there. We're going to be converting this into sine over cos. Cos squared x, okay, it can be this one, but since I already see sine squared x, who knows, they might partner to give us the square identity. So let's just work out the tangent first. So I'm repeating this one, cos x. My target is this tangent. Tan x is sine over cos times cos squared x all over sine x plus at the end there sine squared x. We can freely cancel out cos x with cos x. And do you see what I see? Watch this. Cos x and cos x gone. What do we have left? We are left with this sine x, which will cancel out the sine x at the denominator right there. And in this entire fraction, we are left with cos squared x, which is now adding up with sine squared x. Cos squared x plus sine squared x, that's what we call square identity, and the final answer is equal to 1. No wonder the question here, what did they say? They said determine the value. So in other words, they expected us to get a numerical value. Cos squared x plus sin squared x is equal to 1, and checkmate. Next customer, please determine the value. So we still expect to find a numerical value at the end. Now remember this, guys, whenever we do identities questions, the process is this one. We first check which identity is applicable here so that we may change whatever we are given into some of these identities. Or we check whether we can factorize right away or just use the LCD. Before we even go any further, guys, you will notice here we are given 1, 2 fractions. And since we are given 2 fractions that are subtracting, we must apply the lowest common denominator, the LCD. Now, let me remind you first how the LCD works. If you have A over B subtracting C over D, B and D are the denominators, so we multiply them together to find the LCD. That's B times D. After that, we cross multiply to get our numerators. So A will multiply D, giving us AD, minus B will multiply C, giving us BC. That's what we are going to apply in this question. Let's do it. So in this case, our denominators, we have sine 2x and cos 2x. When we multiply them together, we get sine of 2x times cos 2x. Now for the numerators, we cross multiply. Firstly, sine 6x will multiply cos 2x, giving us sine 6x times cos 2x, minus, then cos 6x will multiply sine 2x. We are getting cos 6x times sine 2x. Okay, let me shift this a bit. So this question is 6 marks. Now, when we continue, guys, we repeat the same process. We must check which of these identities is applicable. Now, watch this. Whenever we see sine, cos, sine, that's psi, psi. We have to suspect we have a compound angle right there. The compound angle that says sine, cos, sine with a minus is this one right here. It's a compound angle identity for sine alpha minus beta. In this case, our angle alpha is 6x and angle beta is 2x. Alpha is 6x and beta is 2x. So all of this expansion can be summarized like this. So in the next step, we write sine of, in brackets, 6x minus 2x. That's the application of compound angle identity. All over, remember Bodmer's rule tells us to deal with the brackets first. It's only after dealing with the brackets we're gonna know how to deal with the denominator. So let's repeat the denominator the way it is. Now, so next we have sine, in brackets here, 6x minus 2x. We use our general knowledge right here, where we subtract the like terms. So 6x minus 2x will give us 4x. Over, let's repeat the denominator again, then we'll see what to do next. Now, in the next step, guys, we still repeat the same process. We check which identity is applicable out of these 6 identities. That's when now we are going to target the bigger number and simplify it into the simpler number. The bigger number here is 4. The simpler number is 2. So what's the relationship between 4 and 2? Well, 4 is a double angle of 2. In other words, which identity are we applying? Double angle identity. So this 4 must be broken into 2 times 2. But we still have x right there. You see what we just did there? Now we have 2x. Even the denominator has 2x and another 2x. So we repeat the denominator the way it is because everything is now written in terms of 2x. Then what's next? Remember, we called this one a double angle, which is a double angle for sine. And this here is the double angle for sine. So we write 2 sine 2x cos 2x. Remember, in the formula, that's written as 2 sine alpha cos alpha. Alpha right here is our 2x, guys. Everything 2x. All over, Now you will notice that that looks exactly like the denominator. So we are repeating the denominator the way it is again. Sine 2x will cancel out sine 2x. Cos 2x will cancel out cos 2x. And what's the final answer? Just 2. And checkmate. Next customer, please. Simplify. Now this question, guys, is for grade 11 and 12. The previous one was for grade 12 only, sorry, grade 11s, but this one is for you as well. Now remember, in each question, we follow this process to start the question. We check which of these 6 identities is applicable. It can be one of them or even more. Let's start with this 720, guys, because that's so unique. This part by itself, it looks like a reduction angle, but let's verify. Remember, in our cast diagram, we start with 0, then 90, 180, 270, and a complete revolution will be 360. So our biggest angle is 360. So this 720, it must be brought back within the domain of 360. Whenever an angle is bigger than 360, what we do, we take our calculators, we subtract 360 from this given angle here. Do it. When you say 720 minus 360, you will get 360. And 360 is the angle we know. We can work with that. So this whole expression can be rewritten as sine of 140 times 720. Now we write it as 360 minus x all over cos 50 times negative 10x. So now we may start. At least we already know that, okay, now so far we know that this part here is a reduction angle. So we are going to work out its sign and see whether sine of 360 minus x is positive or negative. I'm just focusing on the brackets first. So tan of negative x, that has to be negative angles. Tan of negative theta in this case in the notes. And which are the angles about what? The fourth quad. Now remember, if you don't prefer to use a cast diagram, you can just use the alternative method, which I call one and done. In one and done method, where there is x, we put 1. Go ahead, use your calculator, enter sine of 360 minus 1. Where there is x, put 1. What are you getting? You must be getting a negative answer right there. Make sure your calculator, guys, is in degrees mode. So this part, it gave us negative. And tan of negative x, whether you put 1 in the place of x or whether you just remember that in the fourth quad, tan is negative, you are still winning. So this part here is a negative sign right here. So when we start writing the answers, we know already the top part here must be negative and then the tan here must be negative as well. Now, what about 140 and 50 degrees? Watch this. Remember, we have reduction angles and special angles. Reduction angles are 90, 180, and 360. Remember, 270 in CAPS curriculum is not applicable, but if you may know, it works exactly like 90 degrees. Special angles, we have 30 degrees, 45, and 60 degrees. These are the usual special angles we work with. So what we do, guys, we pick one reduction angle and one special angle. When we add or subtract them, they must give us 140 and they must give us 50. Let's start with 140. Now, you will realize that 30 degrees, 45, 60. There is no way we are getting 140 by combining one of these special angles with one of these reduction angles. That's when now we introduce this special angle which you may call unusual. So there's so many ways to do this. My suggestion, between 140 and 50, pick the smaller one, which is 50 degrees. Then break this 140 into 50 degrees and one of the reduction angles. So this unusual, we are calling it 50 degrees in this case. 50 degrees, guys, and which angle right here when we add or subtract them? 50 degrees and which reduction angle when we add and subtract them we get 140. Which one? That will be 90 degrees, because 90 plus 50 will give us 140. So you're gonna break down this 140 into 90 degrees plus 50. See, we are winning already. Then when we get to cos 50 degrees, we are just gonna repeat it the way it is. Okay, the sign of 360 minus x, we already know this is going to give us negative. So we're just going to write negative sine of x. All over cos 50, we write it the way it is, so that it can match the 50 which is already at the numerator. And then now the tan of negative x, we already know is going to be negative tan x. Make sure you write this in brackets since we are multiplying. So next here we clearly have another reduction angle, guys. So we just need to find out the sign. Just for the sign only, just enter sine of 90 plus 50. You will see that you're going to get what? Positive. But since we have 90 degrees, guys, remember what we said in the first question. Angle 90 degrees is what we call co-ratio identity. In other words, we write the co-ratio of sine, which is cos. So that's going to be positive cos of 50 degrees. The top part, we repeat it the way it is because we cannot change it any other way. That's negative sine x. All over, check out this denominator, guys. It's still cos 50, and you can already see some cancelling out coming here. Next part is negative tan x. Which identity is that? That's the tangent identity, where tan is sine over cos. So still in brackets, we have negative. Now be careful, guys. We are not changing the negative. We are only changing tan. Got that? Not the negative, just tan. So this is going to be negative sine x over cos x. Then you close your brackets, you smile, you go to the next part. In the next part, we simply cancel the like factors. Cos 50, cancelling out cos 50. And also, guys, the negatives will cancel out here, so I won't repeat them because negative over negative, that's just positive. So the top part of the fraction, we are left with sine x over sine x over cos x. So this is already looking weird because we have so many fractions. But hey, in maths, our general knowledge, what does it say? The general knowledge says when we have so many fractions like this, the main fraction, which is this one here, the black line, we are going to change it into multiplication. Then after that, we switch the denominator. Sine x, that division line here will become times. Sine over cos will become cos over sine. So we have sine x times cos x over sine x. Cancel. And we are left with cos x and checkmate.